Eutrophication is when we get excessive nutrients, usually from fertilizers. And it's the same stuff that's in lawn fertilizers: nitrogen, phosphorus, potassium. Lawns do have an impact, but it's really agriculture. The fertilizers, the synthetic fertilizers that we put on farms, that stuff washes away with these springtime rains and ends up in our watersheds and causes this problem. So if we have water that is eutrophied or eutrophic, it usually has too much phosphorus or too much nitrogen. Those are the two main ones. So you can see over time, it gets in the water and builds up. And what it leads to is the explosion of algae. Well, those are perfect conditions for the growth of algal blooms. And those become problematic for several reasons. For one, they block the sun because the algae floats on top of the water. And at that point, organisms, plants that go through photosynthesis at the bottom of the water then are not able to get sunlight, and photosynthesis stops. So they potentially can die. And they're responsible for releasing oxygen into the water. So the amount of dissolved oxygen goes away or decreases. And that, of course, then asphyxiates or chokes the other organisms that depend on that. Another thing that happens, and this is on the next slide, but microbes that feed on the algae, they obviously increase and they use up whatever little oxygen is left. So they hog it all. So what I just explained is that top paragraph there. You can see on the bottom left, the diagram shows where a lot of these nutrients are coming from: corn and beans, good old Midwestern farming. So all those Midwestern states, that washes down into the Mississippi River eventually and causes what we call a dead zone. Now, you guys remember the word anthropogenic, I hope. Anthropogenic is human caused. Human causes of eutrophication, of course, are lawn fertilizers, agriculture. Okay, so what happens when all that washes down through the Mississippi watershed? You can see how big the Mississippi watershed is. It is a gigantic funnel between the Rocky and Appalachian Mountains. And so all that water ends up in the Gulf of Mexico and creates a dead zone. Now, we used to see this dead zone show up in the springtime, in the late spring, because the farmers would put the fertilizer down. It would all take a week or two to wash to the Gulf, and then the Gulf would die. What we've seen over the years is that the dead zone is coming earlier and staying longer. So that just means we're using more and more chemicals for longer periods of time. And the concern of environmental scientists is what happens if the dead zone shows up and then never goes away. You can see another vocab word they want you to know. Oligotrophic is the opposite of eutrophic. That's when everything's in balance and we're good. Graphs below show inputs of pollutants into Chesapeake Bay from different rivers. Okay, look on the left, we see that nitrogen is a huge problem coming from the Susquehanna. On the right-hand side, oh, Susquehanna is bad again for sediment that's in the water, but also the Potomac. All right, which of the following strategies will best reduce eutrophication in Chesapeake Bay? Now, at first glance, this is one of those questions where there's a couple answers that maybe could be right, so we're going to have to weed it down. Regulating the use of inorganic fertilizer in the Susquehanna. That seems like a really good answer because nitrogen comes from fertilizer. So we see a direct link there, and it is the biggest, most impactful river. Replacing permeable driving surface with impermeable. That's bad because you're going to have runoff, and that's going to make things worse. Restoring forest ecosystems in the James River. Now, when we have good forests along the banks of water sources, remember that the roots provide natural filtration. That was in the article from yesterday. So that could be a really good thing. The problem here is that sediment is not really the cause of eutrophication. So we don't care about the James River as much. It's not as impactful. Improving septic systems, wastewater treatments, that would be beneficial. So I'm about to show you that sewage treatment can impact eutrophication. But this river is not a significant source of the problem. So the answer here had to be A. It is remember this key word here, which will best reduce. So C and D would help reduce eutrophication, just not as good as choice A. The more litter and waste you have in the stream, the higher the demand for oxygen for those microbes to do their job. Let's say we have a source of pollution. When we get a lot of rain, sometimes the rivers get high, we get flooding. The kids who were outside yesterday saw that the creek is really high on one end right now. And it's by the road. So stuff washes in, litter and sediments off of the street. And so that side of the river is pretty polluted. So there's a lot of biochemical oxygen demand underneath that bridge. That's where it's working hard. And unfortunately, because there's such high demand and it's being used, there's going to be very little dissolved oxygen at that part of the stream. And so we don't expect to see much in the way of life, because what's happening there is the water's been polluted and now it's going through a filtering process or a decomposition process. Now, eventually, a little bit further downstream, things go back to normal. Once they switch places again, the demand goes down, the oxygen levels come back up, and you can expect it to look healthier and see more life. Okay, so what I just explained to you is called an oxygen sag curve, which makes sense. The blue line, the dissolved oxygen, sags. It drops down where the pollution and decomposition is happening. And the important thing here is once you get below a certain concentration of dissolved oxygen, then things can't live there. All has to do with the distance from where the pollution enters. Sometimes sewage treatment plants, and we have one at 96th Street in the White River. When we get a lot of rain and flooding, they have to release untreated sewage sometimes. So that's why the White River gets a bad rep, because every once in a while we're pouring human waste and whatever else goes down our toilets directly into the river without being treated. There's an oxygen sag graph. We see BOD, we see dissolved oxygen, DO. At which of the following locations in the stream was there most likely a discharge of excess organic matter? In other words, raw sewage. Where did the raw sewage get dumped into the stream? Okay, well, it's going to be where we see the big change, right? Would you go with B or C? Yeah, B. Good job. B is the correct answer. We're not meeting tomorrow on Zoom. If you have not done the article yet, make sure you knock that out. It's due at midnight tomorrow night. Bye.